Hello, today I'm going to create a video on how to convert a YOLO object model to a Onnx model. Onnx model is a open neural network exchange where you can convert your model from one framework to another. Okay, and it can be used in different frameworks. So let's not waste time and we just create. So I have here the model here and a video here. Let's create a Python file here. So it's loading. This way it takes the time to load. Okay, fine. So we create a file here. Close this and then save the file. Save the file here. For save. So this is YOLO2 Onnx. Okay, fine. Let's just create some cells. Should be this. Okay, we're going to use ultralytics. Okay, from ultralytics import YOLO. So model, let's specify the model part from where we're going to use it. Model part is going to be from here. Okay, I'll change this. Okay, come on. So my model is best.PyTorch model. Okay, so this is my model. You just load model equal to using this YOLO object. Use the model part here. Let's just see whether this is see what are the class here. Class levels go to, you can get it from the model. Model dot names will return the classes, and you can also find how many classes are there. And just use the length function of this. Okay, let's just print class names. Just use this and we print the number of classes. So we have this. Let's just print, execute this. Oh, error. Base. Oh, here. Execute again. F9. Yeah, there are 3 classes, so these are the names of the classes. Okay, fine. So this is what's it loading? YOLO model. So this is the library or headers. Okay. So once you load, so let's convert this to convert or save Onnx model. So what do we use here? So we need to have the it's a simple function. We can use export. So export what format you want. So we specify Onnx, and we also let's also specify the image size, img sz. So we will declare here image size for YOLO. I'm using V11. It's 640. What is the error here? Image size, probably the it is equal to here. So this is a model, so I have added this. Let me execute this and just execute this one. So it's here. Starting export with Onnx version 1.70. Okay, it's being output here. Let's see. Yeah, it's here. So now what we load this model, load the Onnx model. So we specify where is the path. Onnx path is going to be the same path here, only here instead of PyTorch we will load the Onnx which is being created here. Okay, here to load the Onnx module we need another library. We just import Onnx. Okay, so use this to load the model. Onnx model, this is just for verification. Okay, model, let's go to Onnx.load and we just specify this part. Then we can call a verifier which is there in the Onnx. Check, call it Onnx.checker. Yeah, Onnx.checker check model. You just add it here. You can just print it. Print model verify successfully. Okay, I've added this one, F9. I'll execute this code. Verify successfully. So if you want to verify this outside, you can also verify its neutron. Using this you can verify the Onnx model, or you can rather say Onnx view model viewer. So yeah, it's there. Okay, let's continue further. So once we verify this, what do we need to do? We will create a session. Okay, create Onnx session. Or you can add inference session. So this is from the Onnx runtime. So again we need to import Onnx runtime as Onnx runtime. Okay, so here how do? We create a session using Onnx runtime session node session. That's why use the word inference session. Yes, so here we just specify the model part. session, but we also need to get the input names and output names from this session. Okay, so session dot get inputs. So normally input is only one input, then we get the name. So YOLO is only one input. If you have any other model which is more than one input, then it's going to be different. You can use a for loop to iterate and extract all the inputs. So output names. So YOLO has more than one output. Okay, so we extract one by one and then get the name from output. For output in session dot get outputs. Okay, so then out put dot to get the names. It should be name. Okay, so let's execute this and then see. Runtime, execute this, then you execute this one. Instead, what is the output name? Output name is output.0 and my input name is images. Okay, perfect. Okay, so now what do? We will load the video. Okay, load the video file or video. Okay, so video file name code is going to be the same folder. So what is the video name? video1.mov. So we do it here, video1.mov. okay, and for this let's use OpenCV. Open import CV2 as CV. Okay, so you in the capture, go to cv2.video capture. Is it capture? Yeah, capture, and you just use this. Okay, perfect. So what do we do now? Once you load, what do? We display the video. Okay, so while your capture is still open, capture dot is open, then we will continue. Is this correct? Yeah. So result is success or failures. Success, or this will be the image. Capture dot read the image one by one. So if it is successful in reading the image, okay, we just display the image. So how do we do? cv.imshow. Yeah, so first is the image, first is the string, so the name is the video image. Okay, you can give any name here. Let's just see whether this video get displayed properly or not. Success if cv.wait key it, yeah, cv dot width key equal to 1, and when the user press 0x and the user press q, we exit. Okay, close it. Equal, not a sign. Is this correct? This is wrong. It's wrong one. Yeah. Okay, then we break. If not succeed also, we break. Okay, what is missing here? Ox hex. The start O is 0. Okay, let's run this. We added this. Okay, let's see whether we can run this. That's my CV is not defined, so we just run this here one time. We run this. Capture is not defined, and we need to run this whole thing. That's my here. The image is displayed here. Okay, fine. It's perfect. So it stops. Okay. Okay, fine. Then we are missing something here. We need to release the resources and the capture. Okay, it's capture dot release and cv dot destroy all window. vstr all windows. Okay, fine. Let's save it, rerun it. F9. Yeah, so let's press Q. Let's close. Okay, fine, perfect. Hello. Yeah, so we have the image here. So what do we do here now? We will take this image and then pass it to the session, and we will get the output. Okay, so image, go to, so one thing here is like the image we get may not is not some random size, but to pass to this model we need to specify, to pass to this yellow model we need to have we need to resize to 640. Okay, so we will resize that this image, cv dot resize, so what's my source? My source is this, and then what is my size of the image? 640 by 640. Okay, so probably this is the resize image. Okay, so then what do we do? Even after this resize, we cannot directly pass this image to the session because this is in OpenCV matte image, and here it takes the different inputs. Okay, so probably we need to convert this to tensors. Okay, Onnx tensors. So input and r tensor equal to resize dot let's convert this to let's convert the image format to float 32, because normally most of the neural network uses float variable, float types. Yeah, and then what do we also do? resize. We call it sampling, scaling down from each of the pixels is numpy. So we need to import numpy here. Import numpy as np. So what I was talking here is we need to convert this to float 32, and then we will scale down the image from 0 to 255, from 0 to 255 to 0 to 1. Each of the image pixel has a value between 0 to 255, so we will scale down this to 0 to 1. So this is scaling down. We further need certain other things, and we need to resize, reshape, so to say. Reshape in the sense transpose, yeah. So in OpenCV, the image is in the format height, width, and the channels. We don't need that. We need channels, width and height. Okay. So here we just swap this, swap the positions. Okay. So this becomes channel. This becomes height and width. Okay. 0 is height, 1 is width, and 2 is channel in OpenCV. So we just transpose this. Then after that, we do one more thing again. np.transpose, missing one parameter here, and just one function. Okay, then again this is of just two size. The image is of width and height, and here we need to add one more axis for batch size. Batch size should be at the top. Expand the dimension or add one more dimension. Expand the dimension of input tensor, where you're going to add in the first index. Okay, so now we have the tensor here. These tensor we can directly use in the session. Okay, so session dot run. So what do we need to specify in the session? Session dot run first should be output names, output names or output name. I use the names here, so I should use this. Okay, and then we also need to specify the input names, but we need one more parameter here. This is the names. Okay, and then we need to add the input tensor here. Okay, that's it. Pretty simple. This can be like a dictionary. So, and then we will get the outputs. It can be more than one dimension. So we have this. Okay, outputs go to output. If you display this without filtering, it will be very messy. Okay, so what do we do now? What's detections? So let's just filter this. You cannot display everything here. For detection in outputs, since output we don't need, we only need the first. Okay, so the outputs probably it's going to have in the YOLO, the output, the first four is the coordinate x, y, width and height, and the next in the YOLO version 6, 7, 5, 6, 7 something, the fifth is the confidence score, and 6, 7, 8 after that is the probability of all the classes. But here in YOLO v1, the first four is the same like coordinates x, y, width and height. Starting from the fifth it's the probability, it doesn't have the confidence score. Okay, so when I was trying to extract this, I was always having one class less than the actual output, which is like which have YOLO 5, 6, 4, all those things. So I have to ignore the confidence index, and then from the probability I have to calculate the score again, confidence score again. Okay, so let's do this. Boxes is xy, boxes equal to, from the detection, first four is the boxes. Okay, then we have the probability. I'm going to use I'm going to filter again, so I'm going to use one more probability. So detection here, so this thing is it's only 3 classes, so 4 plus 3 is 7. Okay, so this is my probability, and then what do I do? What is my class? What should be my class ID? Class ID is, from the probability, the max value is going to be my class ID. Okay, so we can use NumPy to calculate the maximum value for arg max probability axis equal to 0. Okay, so this is my class, and then what should be my score? Probability score. I'm going to use one more for loop for non-maxima suppression. Equal to probability of this class, probability of the highest class. P dot arrange probability dot CFO1. Okay, so we do the this. Before this, it will display all the boxes about 8400 box if we don't filter. So let's filter here, confidence threshold. So let's give 1.2 0.2, that's 20%. So if the probability score greater than or equal to this confidence score, then only we display. Okay, then only we add. So if okay, fine. So what do we do here? So if this then we will have we don't need if. So we in Python we can just directly use marks. So this marks will return the indexes. So it will reduce, it will filter a lot. Okay. What do we do here? So indices equal to np dot where marks, we are getting the indexes of the rectangle, so of the rectangle where the score is greater than the threshold, greater than 20%. Okay, we can print length of, let's just see what is missing here. So let's just see how many classes it's able to fetch. We need the numpy, that's 9. So let's print and py.array input names, input tensor. Okay, there's an error here. The error is here. Let's see what is wrong here. Oh, it's not a, it's a bit dictionary. Dictionary should be a colon. Yeah, not comma. So F9. Slow and 1 1 1. No. It's not. Oh, I display for every check where I'm displaying length of indices. Indices output 1, length of indices. We should display more. Marks, you have confidence threshold. Oh, here it's wrong. Okay, should not be the confidence threshold, it should be this one. So we can see how many classes it detects. Yeah, there are 18, 20, so many boxes. Okay, so let us escape. Okay, let's see what happens if we do not use the non-maxima separation. What will happen to the outputs? Okay, so for we display all the boxes, which is where the confidence is greater than 20%. Okay, so I comma 2, probably comma 1. So okay, let it be this one. Flag index for this enumerate. So we browse the indexes one by one. Browse the indexes one by one, and then what do? We just add the detections. Okay, detections dot append. Let's just add all the boxes. B box, a dictionary. So box is this, and confidence confidence is going to be this probably score. We need one more class ID. This probably is going to be this one. We put everything in the detection, and then so let's fetch everything from the detection and display in detections. Detections, so we need to get x, y, width, comma, height. So from detect, so this is the box. From the box we get all the boxes. We can also get the class. What is my class? Same, the class ID. Okay, and then classy found score maybe. Found score, so we use this. So this is the confidence, and then we just print it on the image. CV dot, we need to display the rectangle, CT in this rectangle, in this image we need to draw the rectangle again. This rectangle is the center and the width and the height, so we need to convert into top left, bottom right. For that we need to do it again. Left equal to x minus x minus width divided by 2.0, x minus width divided by 2, 1, 2, 3, okay. Left, top is y and height, then bottom is x plus width, and then bottom right, this is right, and bottom is height, so this is going to be y plus height. Okay, so what is wrong here? Detection, so here probably class ID probably score. What is wrong here? Format. Let me complete this. Then you need to specify in the rectangle, you can just specify here, make sure to use int. Left, top, right, bottom, use int everywhere. And video is getting longer and longer. And color uses directly use BGR, so B is 0, green. Okay, so let's make the thickness to 3. Okay, so this is rectangle, so what is inflex dot append? Property score. Let the box append. Well, here dictionary should always be within this. So I have this, let me check, let me run F9. Is there an error? No error. And exiting F9. Okay, CV rectangle, only one, it can be converted to Python scale. Okay, it's here. We close this. These two is top left or left top, and these two is right bottom. Yeah, so let's try F9 0 2.5. Missing here, missing something here. So what do we do here? Let's just display this str font class. So F9, only one lang one array can be converted to Python scalable. Is this one? So we have the image, we have this thing. Oh, we don't need rectangle. Right, left, top, right, and bottom. Okay, so here, okay, it's here. Left top, one here, and then we do here. Left top, right, bottom, and then this is the color, and this is the thickness. Okay, F9. It's here, top left, in top left. So it's here, left, top. We have the image, we have the left, okay, left, top, right, bottom, okay. We have a problem here, so we are in the detection, we are adding the boxes which is having more than one indexes. It's an array of indexes, so we need to filter this. We need to index, add only that particular indexes. It's wrong, this is wrong here in the detection. Okay, so we'll change the code.